Hello guys, my name is Desmond and I welcome you to my lesson for today where we'll be looking at your mathematics. As indicated, we will be looking at functions. So ladies and gentlemen, please do allow me to say it is very much important that I say it is very much important because what I'm about to say, it's massively. Hey, massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. By so saying, please, come on. Please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very much important, ladies and gentlemen, over there. So, as I've indicated and as per our timetable, today we'll be focusing on grade 10. But most importantly, in case if you are in grade 11 and 12, and you are not confident with functions, please do remain in this lesson just so that you are able to notice where the functions are coming from. So now I want to make everyone aware that we study mainly 4 types of functions. Number 1 being what we call a straight line. Number 2, parabola. Number 3, hyperbola. Number 4, exponential. So these are the 4 main type of functions that we will be looking at. So obviously, I will consider this lesson to be an introduction for grade 10 learners. So the standard will be limited to this specific grade. But most importantly, guys, we will be talking a little bit more about a straight line. The word straight itself explanatory. So that means we'll be looking at a line which is straight. But I want to tell you now, Tandy, that these functions 1, 2, 3, 4, they are not just drawn anywhere on the paper. You don't just draw a straight line anywhere on the paper. We draw functions on something called a Cartesian plane. Here comes a question. What is a Cartesian plane? Guys, a Cartesian plane, it's a something looking similar to that, where you have this horizontal straight line called the x-axis. You also have this vertical y-axis called a vertical straight line called the y-axis. So this is going to be the x-axis. And most importantly, guys, at where these 2 lines intersect is what we call the origin. So it's more like this is the starting point. So that's why sometimes they just do a 0 looking like that, or otherwise they can just put a 0 there, or a 0 there, a 0 there, a 0 there. Just know that this 0, it actually refers to that point of intersection. That's what we call the origin. So that's all that you need to know regarding what we call a Cartesian plane. So a Cartesian plane, Bantu Bakiti, in simple terms, it's more like a plate. Mzozozo. This is a plate where you put in the food inside the plate. So there is your pap, there is your chicken, and then you've got some gravy there. So to make sense out of this, I'm just saying we draw functions on a Cartesian plane. You put food inside a plate. So let me just try to repeat that using the same words, even though they might not be relevant. This is what I'm saying. We draw 1, 2, 3, 4 being the functions on a Cartesian plane. We put food being 1, 2, 3, 4 on a plate. So that means without a plate, you cannot put the food. Without a Cartesian plane, you cannot draw the functions. So that means at all the times, when you are dealing with functions, you need to ask yourself firstly, where is the x-axis and where is the y-axis? Then you know this is the origin. That's all that you need to know regarding a Cartesian plane. So now we've got this type of a function called a straight line. Otherwise, others can say it's a linear function, but it simply refers to a line being a straight line. So how does a straight line look on a Cartesian plane? But most importantly, before we even indicate all of that, let's quickly explore some additional information with regards to a Cartesian plane. Remember, this is the x-axis, y-axis, this is the origin. But you might realize that we actually have 4 quarters. We have 4 quarters. The quarter J4 lerato. If you have it could be an apple or an orange. So you have that vertical line that cuts your orange into 2 equal halves, and you still have that line. It now cuts it into 4 quarters. That's what I mean by 4 quarters. So this is quarter number 1, this is quarter number 2, this is quarter number 3, this is quarter number 4. That is why we can refer to this quarter as a first quadrant. This is therefore going to be the second quadrant, third quadrant, fourth quadrant. So that means an additional information that you need to be aware of in relation to a Cartesian plane is the fact that it has the first quadrant, or quadrant number 1, quadrant number 2, quadrant number 3, and then lastly we have quadrant number 4. With you understanding all this information regarding the quadrants, you will have a better understanding when it comes to trigonometry. So let's see, how does a straight line look like? That's where I'm preparing you. So remember guys, we have x values on the right side of the origin. We also have x values on the left side of the origin. Similarly, with the y values, we have y values above and y values below. So the x values on the right side of the origin are positive. For example, positive 1, positive 2, positive 3, and so forth. And then on this side is going to be negative 1, negative 2, negative 3, negative 4, and so forth. And then above, positive 1, positive 2, positive 3, positive 4. Below, negative 1, negative 2, negative 3, negative 4, negative 5, and so forth. So this is how a Cartesian plane looks like. So mathematically, for you to draw a straight line, you need two things. You need two things for you to draw a straight line. Remember, guys, today's lesson is for grade 10 learners, which means the standard is maintained and limited to that grade. But most importantly, everyone is encouraged to remain because everything builds up from what I'm explaining today. Meaning, when we get to grade 11 and 12, the intro will be completely different with an assumption that you do know all that I'm explaining today. Okay, so now, most importantly, I've just emphasized the fact that you need two things. Listen very carefully. I've just said two things. So we are now about to use the correct words instead of things. What are those two things that you need? Those are what we call the coordinates or the points. So if you're making some notes, you can say we need 2 points or 2 coordinates. What are the coordinates, Bantu Bakiti? The coordinates are in this format of X and Y. The moment you start seeing that, just know you are dealing with the coordinates. So you need 2 points or 2 coordinates in order to draw a straight line. Let's say, for example, you have 2 coordinates being 2 and 3. Let's say this is point A or the coordinates of point A, and then maybe point B, we are having, let's say, negative 3 and negative 4. So for you, okay, excuse me. So I wanted to say, you have point A and point B. So let's now try to locate point A. So that means we need to try and find where X is 2 and where Y is 3. Let's see, where is that? This is X1, this is X2, and then where Y is 3, it's 1, 2, 3. So that means the point where X is 2 and Y is 3 is that point there, which is point A being 2 and 3. So now let's try to locate that point. So at that point, that's where you have your X being negative 3. Let's see, negative 1, negative 2, negative 3, where Y is negative 4. Negative 1, negative 2, negative 3, negative 4. So that point is that one there. So can you see, you now have your second point being point B, being that. So that's what I meant when I said you need two things in order for you to draw a straight line. All you do is to use your ruler and you connect those 2 points. This is the simplest part of sketching a straight line when given 2 points. We are now going to move on to something which might be not necessarily complicated, but is doable, but it could be a bit tricky sometimes. Guys, are we still together before I go deep?
Yes, sir. Usually.
Guys, I couldn't hear that. I'm not sure if okay, then it's fine. I will continue. So now what you did was to plot the 2 points. Let me say to locate the 2 points, and then you plotted a straight line based on those 2 points. So now you can be given something similar to that, and they request you to origin of that straight line. So that means they give you a straight line and 2 points, and they ask you to determine an equation of a straight line. So this is the general formula for calculating a straight line. Y is equals to mx plus c. This is the general formula for calculating for deriving an equation of a straight line. So y is the y from that y axis, and then x is the x from that x axis. And then c, they normally call it the y cut. I will explain shortly why they say is the y cut. And then m is the gradient or the slope of a line. And m has got a formula being change in y over change in x. This symbol being changed, it simply means this 2 minus this 1, which means it's y2 minus y1 over x2 minus x1. Again, for you to determine the formula of a straight line, you need 2 things, just like you needed 2 things to plot that straight line. So maybe let's quickly try to think of a different scenario where we are given an information and we need to determine an equation of a straight line. So obviously, first thing first, a Cartesian plane having the x and the y axis. Let's say you have a straight line similar to that. You are given maybe this point being point A, where x maybe is 5, and then y is -2. And then you're given another point, let's say it's point B, where x is -2, and then y, let's say, is 4. So remember, from the origin towards this side, x values are positive. From that to this side, x values are negative. From the origin upwards, that from the origin downwards, the way values are negative. So that is why you are going to have a positive x value and a negative x value. You just know that this negative y, it actually refers to that y there. And then this 5, it refers to that. And then this side, that x of -2, it refers to that -2 there. And then +4, it refers to that 4 there. So what could be confusing to you as a grade 10 learner it's not being able to interpret this given information. But you need to be aware that as far as a straight line is concerned, you are dealing with two things. Those things are what we call the 2 points or 2 coordinates. So we just said the general formula is y is equals to mx plus c. So now the steps to follow when determining an equation of a straight line. You firstly need to determine the gradient, which is you change in y over you change in x, which is y2 minus y1 over x2 minus x1. You just need to substitute those two values. So you need to decide between these two coordinates or those 2 points, which one will be your x1, y1, and which one will be your x2, y2. This is what I normally do. Obviously, alphabetically, you start from letter A, and then the next is going to be letter B. So this is the first letter. That is why it's going to be my ones, and then these are going to be the twos. Meaning, this is going to be my x1, y1. This is going to be my x2, y2, following the order of alphabets, which means you might be given point KS. You need to know between K and S which letter comes first so that you can assign the x1, y1, x2, y2. So let's quickly substitute and punch on your calculator. So let's see. What will be our y2? It's going to be -4. Most importantly, put it inside the brackets. No, not -4, +4. I was actually looking at that. Let me remove that because we've dealt with those coordinates. So that means you don't need to put it inside the brackets because it's a positive value being 4. Minus from the formula, let's see, our y1 is negative, we put it inside the brackets. What is our x2? It's a negative value, which is -2, minus what is our x1 is that. This is equals to, what is that? This is 5 over -7. I think it ends as that. So this is actually the gradient of that straight line. So we can now take our gradient and substitute it into that. So that means we're having y, which is equals to -5 over 7x plus c. So I just want you guys to be aware that when you determine an equation of a straight line, they just want you to give the gradient and the c value. That's all. So can you guys see that we've actually determined the gradient? That's why we substituted it there. So now what's missing is c. So for you to determine c, you can use any value between those two. You just choose any value that you like. Someone please use A, the other one please use B. So I'm going to use A. Let's see how do we use A. So that means where we see X, we're going to substitute 5. Where we see Y, we're going to substitute -1. So that means we're having -1 is equals to -5 over 7. Inside the brackets, we are having our x being that plus c. What are we doing there, guys? We are actually trying to get the c value, because once we get the c value, it means we have determined all that we need to know in order to provide an equation of a straight line. So that means you will need to multiply that by that, I think it's negative 25 over 7. You have a negative 1, then you transpose. You're going to have a negative 1 plus 25 over 7, which is going to be equals to C. So what is the C value?
18 over 7.
Positive 18 over 7.
Yes.
Okay, so now it means an equation of a straight line. It is y is equals to, what is our gradient? We calculated it to be negative 25 over 7 x plus, what was our C? It's 18 over 7. So that's how you determine an equation of a straight line where you are given 2 points. Remember, guys, I'm going to provide limited information so that you don't get confused. I'm just trying to avoid you guys consuming a lot of information at once. So I'm just going to explain all that you need to be aware of. But remember, as I've indicated on our previous lessons, we will spend our time on this chapter of functions so that all of you guys will be confident before we move on to the next chapter. But most importantly, please make sure that all the lessons related to functions, don't miss those, because it's going to get deeper as we continue. Here we are just doing an introduction, of which it will obviously be easy to understand. To some, it will be boring because they already have an idea of where we are headed to. But if you find this confusing, please make sure to try and revise all of this so that on our next lesson, you will have an idea of what is going on. So let's say for now, that's what you needed to be aware of regarding a straight line. But now I'm going to summarize something. So this is what happens on a Cartesian plane. Someone remember to mute your mic. Let me quickly see who's on the line and have their mic unmuted. Leah Suma, okay. Leah Suma muted them. Okay, so let's see. This is what I was about to summarize. For a straight line that either starts or ends in this quadrant and that quadrant. So that means a straight line that passes through quadrant number 1 and quadrant number 3. They always have a positive gradient. And then a quadrant that passes through quadrant number 2 and quadrant number 4, they always have a negative gradient. So just quickly give you an example. A straight line similar to that. Can you see? It passes through quadrant number 1 and a quadrant number 3. So that means when you calculate your gradient, which is change in y over change in x, y2 minus y1 over that, you are going to have a positive gradient. If you find a negative gradient, just know you've done a mistake somewhere. So that means all the straight lines passing through there, so that is why I'm saying they either end in that quadrant or they start in that quadrant. They will all have positive gradients. But all these lines, they will always have a negative gradient because they end in Q4 and a Q2. So that means always when you are dealing with a straight line and you notice it ends in that quadrant and that quadrant, just know or expect a negative gradient. So I think for now, that's all that you need to be aware of regarding a straight line. Maybe I think it's worth it to just squeeze in this information. We're having y there, we're having x there. So if you have a straight line similar to that, let's try to analyze that straight line. Remember, the general formula is y is equals to mx plus c. So here comes a question. Maybe you guys can give it a try just to check if you guys understand. Are we having a negative or a positive m for that straight line, and why? For whichever answer that you choose.
It's a positive gradient because of the line goes through the first quadrant and the third one.
Yes, 100%. So that's all that we know regarding that. So this is what you need to understand on a straight line equation, how that m operates, or the influence of that m on a straight line. So that means if you had to calculate the gradient of that line, you're going to find a positive gradient. So now let's quickly discuss that c value, because on a straight line, these are the two most important things that you need to be able to interpret. So remember, this is the origin. So with regards to C, when I was saying it's actually a y cut, so that's where your straight line cuts the y axis. So if it cuts the y axis above the origin, that is where obviously y is greater than a 0. So anything from the origin going up, you're going to have a positive C value. But if you have that line, one thing for sure, the gradient is still positive because it ends in the first and the third quadrant. But with regards to the C value, can you see it is at where y is below 0? So this thing, it means y above 0. And this one, y below 0. So can you see? This is the 0 being the origin. And this cuts the y-axis below the 0. So that is why we are saying here you're going to have a positive C value. Here you're going to have a negative C value. So for example, for similar to, let's say y is quite a minus 3. This maybe for that one, it would be y is equal to x. But the most, the is positive and is positive visible one. In this case, it's negative 3. Have a because it ends in a quadrant. And with regard to, you can see that it the y equals 0, meaning we want to have a positive value, and then one is going to be so one. You might have something similar to y equals 2, let's say already maybe negative 3 over 2x, and then the C value is positive 7. Just as an example, that. And below could be a 1 plus 2 a over C. As an example, what you need to be aware of is that negative and C value is negative. Base resistance and also the so that was a straight equation. So now maybe quickly try and discuss a hyperbola. Try and quickly discuss hyperbola. General form of a hyperbola is equal to one x. The general equation of a hyperbola.
You are cutting. We are not hearing you very well.
In a sense, it is a simple. If required, for now, they don't need explanation. Now,
Sir, we can hear you.
We
You need so what to do to that. Remember, function on a cottage place and explain things.
we can't hear you. You are cutting. You have been cutting for a while now.
Is it cutting for everyone?
Yes, sir, it's cutting.
Is
Yes,
it
sir.
on side? To check try something. Guys, okay, let me join. Yes, I'll quickly less than a minute to disconnect Wi-Fi. So don't go in. How about now? Is it still breaking?
It sounds clear.
No.
So it's clear for everyone.
Yes, sir.
Sure. Something that I'm not sure of is at what point did it start breaking. So remember, guys, it remains your responsibility to make sure that the moment it starts breaking, you let me know so that I can do something. This is so that in the future, when you want to catch up, this recorded lesson won't be breaking, because if it breaks, then you won't be able to get all that was explained in this lesson. So if it happens again, it's starting to break.
No. It started from the equation y is equal to a over x.
Oh,
so the entire explanation was not clear. We did not hear what you said there.
Okay. Luckily, it's not much that you missed. Maybe let me do this and say we are now moving to a hyperbola. So a hyperbola, the general formula is y is equals to a over x. This is the general formula. So what I was saying is the y and the x, they don't need an explanation. As far as functions are concerned, x and y, no need for you to dig more on those. But the moment you start seeing a foreign letter, in this case is a, then we need to understand what is the impact of a on that function of hyperbola. For example, we have dealt with a straight line being y is equals to x plus c. So 1, 2, no need to worry about those. Foreign letter, it was the a, of which we said is the gradient being the change in y over the change in x. Another one was c, of which we said c is the y cut. So here, I was saying a hyperbola, it's easy, very, very much easy and straightforward because it's only the a letter that you need to be concerned about. So what I'm about to explain now is the impact of a on a function. So let's see. Okay, this is where I was. I was saying there's no way you can talk about a function without you referring to a Cartesian plane. This is a Cartesian plane having the x and the y axis, quadrant 1, quadrant 2, quadrant 3, quadrant 4. So now let's try to understand the impact of that a value. This is what they say, Bantu Bakit. They say if a is greater than 0, then the graph will be in quadrant number 1 and quadrant number 2. If a value is less than 0, the graph will be in quadrant number 2 and quadrant, I'll correct that. It's going to be quadrant number 2 and quadrant number 4. This is what I need to correct, is quadrant number 3. Something which might be a bit confusing is you not being able to interpret that a being greater than 0 or a being less than 0. So that's another factor that contributes towards maths being complicated or confusing. When they say when the a value is greater than 0, anything greater than 0 is a positive number. Anything less than 0, it's a negative number. So just to be practical, it's more like if you are given y, it's equals to 2 over x. The shape of a hyperbola is like that. Why am I drawing it in the first and the third quadrant? It's because the a value is greater than 0. So can you see the a value is 2, it's greater than 0. But if we had something like y is equals to negative 3 over x, can you see the a value is less than 0? The a value is less than 0. What makes it to be less than 0 is because of that negative. So that means it's going to be in the second and the fourth quadrant. But to draw a hyperbola, you don't just do that and that. This is how you draw a hyperbola. So I'm just going to quickly remove all of that. Maybe let me also remove all of that, and then let's try to sketch this function of y is equals to positive 2 over x. Obviously, you will sketch it on a Cartesian plane, having the y and the x axis. That's a Cartesian plane. So how you plot it, you can say Where x is 1, what is going to be the y value? Where x is 2, where x is 3, where x is 4, where x is 5. So that means you need to take out your calculator and say 2 over. If you punch 0, starting from 0, it gives you an error. There's a reason for that. That means your function will never touch either the y or the x axis. It never touches the x-axis or the y-axis. That's why it gives you error when you substitute 0 where you see x. So because it failed with 0, it means 0, 1 is going to allow 0, 2, 0, 3, 0, but to be realistic, let's work with 1, 2, 3, 4, 5. We'll stress about those 0, something on exam questions. But for now, for the sake of being clear as I explain, let's work on those. Maybe let's say here we're having 1, 2, 3, and 4. So to plot or to sketch, you say where x is 1, what is y? That is why the coordinates are in that format of x and y. When you plot, you say where x is what is y? So where x is 1, what will be y? Let's substitute 1 there. What are you getting? Is 2 divided by 1, which is 2. So that means where x is 1, y is 2. You can maybe put a dot there. Then you move on to the next point and say where x is 2, what is y? So it's more like it's 2 divided by 2, which is what? Is 1. So you are going to put a dot there. Then you can maybe use this as a last point, just so that it guides you in terms of how the shape will look like. So that means you're having 2 over 3. What is 2 over 3? Let's see. 2 divided by 3 as a decimal is 0, 6. So that means it's actually between 0 and 1. You can just make an estimation to say maybe it's somewhere there. So can you guys see? It therefore follows that shape. It just get closer to the x-axis, but it never touch. It never cross. So that's how the shape looks like. So you just repeat that same shape on this side. You don't need to recalculate it again on this side. You can just by hand redraw it. Remember, it shouldn't touch that line or cross. It shouldn't touch that line or cross. So that's how you sketch that. Maybe quickly, let's try to plot or sketch this one of y. It's equals to negative, maybe let's say 3 over x. Let's try to sketch that one. What you should know is in which quadrant is our function going to be. Is it going to be in the first and the third, or is it going to be there and there? What tells you is the sign of that a value. So if the sign of that a value is negative, then it means it's going to be in this quadrant and that quadrant. Remember, guys, I'm well aware that I did skip that. Don't worry that much. I skipped it on purpose. So that means today we are focusing on those two. Okay, so now let's quickly try to plot that one. So that means you're going to say where x is whatever, what will be the corresponding y value. So that means you're going to say fraction button -3 at the bottom. Let's maybe start at where x is negative 1. Why negative 1? Because you know that your function is going to be in this quadrant and also in that quadrant as well. So it seems like whether you use negative 1 or 1, it doesn't really matter that much. So maybe since we realize that it doesn't matter whether you use negative 1 or positive 1, let's maybe continue with the positive values. So let's say negative 3 over 1. What is it? It's negative 3. So that means where x is 1, the corresponding y value is going to be negative 3. Let's go to another point where it is 2 as a decimal, it's negative 1.5. Negative 1 is there, negative 2 is there. So negative 1.5 is somewhere in the middle, in between. So that means where x is 2, the corresponding y value is that. Let's see maybe where x is 3. Where x is 3, it's negative 1. Can you see where x is 3, y value you get negative 1, you're going to put a dot there. So already you can see the trend. Then you might not need to stress that much about calculating everything, but just connect the dots. You just know very well that it actually tries to get closer to the x-axis and the y-axis. Most importantly, it never touch, it never cross. You do the same that side. By freehand, you can just do that. So that's how you plot a hyperbola. So it's in most cases where we do two things under functions. It's either you plot or you determine an equation of a straight line. Not necessarily a straight line, but it's either you plot or you determine an equation of a function, or you determine equation or otherwise you plot. It's only those two things that we normally do. So let me remove all of this and we try to determine an equation. What we have done, it was just to plot. Let's say on a Cartesian plane, for some reason, you are given something similar to that. What examiner would do is just to give you 1 point and say maybe this is point M for Maria, and then they say this is where x is 2, and then the corresponding y value, let's say it is what? It is 1. And then they say determine an equation of that line. So we know that generally the equation of a hyperbola is a over x. So you need that point in order for you to determine the a value. Just like we did with a straight line, we needed 2 points to determine the m and the c, because we always want to have our equation in a form of x and y. If we have other letters, we need to find their actual values. So in this case, it means it's only letter A that we need to stress about. That is why for determining an equation of a hyperbola, you only need 1 point. Why 1 point? Because you just need one unknown. Unlike on a straight line, you needed 2 unknowns. So where you see x, you're going to substitute 2. Where you see y, you're going to substitute 1. Then you solve for the unknown. So that means you're having what is it? Y is 2, which is equals to a over x is what? X is 2. Then we just cross multiply. That means 2. That times that is 2 is equals to a. So that means your a is equals to 2. Then your formula is going to be y is equals to 2 over x. Then this is the formula for that function of a hyperbola. It is as easy as that. But now, this is where it gets interesting. You have a hyperbola there. At the same time, there is a straight line. You now have two functions now. It's now two functions. You have a hyperbola at the same time on the same set of axes. You still have a straight line. Maybe they give you that point there and they say that point is -2. And they ask you questions based on that. This is where it gets interesting. So that is why I had to encourage everyone to attend this lesson, because it builds up from this simple information. So now, what questions can be asked there? For example, they can ask you questions based on that straight line or on that hyperbola. But when they ask questions, how are you going to know which formula or which function are they referring to? Because we say for hyperbola is y is equals to a over x. For straight line is still y, it's equals to mx plus c. So maybe let me ask you, Moleboge, if they say determine an equation of a line, is it going to be easy for you to know which line are they talking about, Moleboge? They just say determine an equation of a line.
Yes, it's going to be easy given the straight line only there. I would know what they are referring to that line.
I think yes, because of that word being a line. Maybe let me try to do this so that you get my point. Let's say you are given that line and that line. This is y, this is x. Let's maybe forget about that and say there. If they say determine an equation of a line, are you going to know which line they are referring to? Is it easy to know which line they are talking about?
If they've just said a line,
Yes.
and there are two, it's not. I
And
think
you
I'll
see,
take one there, but it's not going to be that easy.
exactly my point. That's what I wanted to actually explain, to say it's not easy. It's almost impossible to know which one they are referring to. That is why they make use of letters such as Bra George. There's another one, I think is Kulu. So they use letter H. I think also Brahma Franco. Yes, even Brahma Franco. So, who else? I'm not sure if there's another one. I think, yeah, it was these three guys, Moleboge, who thought of what you went through to say, how are they going to know which one we are referring to? So, Gildas said, okay, we'll name one function g of x. And then Blue said, we'll name another one h of x. And then Mafranco said, okay, if it's three functions on one Cartesian plane, maybe we have another one. Then we'll name that one f of x. So you shouldn't stress when you see this f of x, h of x, and g of x. They are just meant to differentiate between those functions there. So that is why we can just refer to this one. Instead of saying y, we can maybe just say this is g of x. This one, instead of saying y, we say it's f of x. But at the back of your mind, you should always know that g of x, it's actually y. They can't write y because it's too many functions there and they need to be specific when they ask. So also this one is one. I'm not sure. Does it make sense now, Molebo? Because if you understand this part, you won't get confused when they say g of x, f of x, whatever. So
I understand clearly.
that's what I wanted you guys to be aware of. To say, now I'm about to derive some questions based on what we are having there. That's when it gets interesting. So let's see. Maybe let's say a straight line is the graph of f. Can you see what they do? They just write f there, and then next to that line they just write a g there. Then you need to know that this one, it goes hand in hand with that one. Never make a mistake of sketching a hyperbola and you just draw that line and you forget about that one. It has to be this one and then that one freehand you can do, or you do that one then this one freehand. So that means it now gets a bit complicated where you have the f's, you have x and y, but I'm sure that it's not even confusing because you know very well that we draw functions on a Cartesian plane. That is why I said we start with the Cartesian plane and then what comes after is the functions. So this is the general formula of a hyperbola. This is the general formula of a straight line. So now let me try to derive some questions based on that. This is how they might ask you in exam. They can say, determine an equation of a straight line. It might be confusing for someone, but guess what? You always need a receipt for almost everything that you do. If you can have a receipt, it's going to be easy. I'm not sure if you guys remember that. I said, let's say the question says find a f of x. Find a equation, not just f of x, but they say find equation of f of x. Anyone who knows whether they want an equation of a hyperbola or a straight line. Guys, Alex, did you get the question there?
Yes, I'm still thinking.
So the question was,
To the graph
how
that you have already,
yes, go for
is
it.
that question, is what I wanted to know, is the question that you are referring to, the question that you've
Yes,
just posed, referring to the graph here, referring to this
yes.
graph?
So the question says on this Cartesian plane, find
Yes,
equation of f of x. So the question is, are they talking about a hyperbola or a straight line?
a straight line.
How do you know they want you to determine an equation of a straight line?
Because you've already labeled that straight line
Yes,
f of x.
yes, f of x, exactly that. So that means you need to know the general formula of a straight line. Is it not y is equals to mx plus c? So the recipe that I was talking about is that when you determine an equation of a straight line, I said you need things. What were those things, Bantu Bakit? I'm not sure if I said 10 things or 3 things.
Two coordinates.
What did I say?
2 coordinates or 2
Two
points.
coordinates.
Yes, 2 coordinates of or 2 points. Do we have those? Because we need the 2 points or 2 coordinates. The question is, do we have those?
Yes.
Yeah, two and
Yes.
and 1.
2 and 1. That one there, okay? 2 and 1. Where is another point?
0
Isn't it 0 and 2?
Oh,
0 and
yes,
negative
yes,
2.
yes. 0 and negative 2. So, can you guys see? We are just going to save some time and say exactly what I did in the beginning of this lesson to determine an equation of a straight line. You do exactly the same thing using those 2 points. So the tricky part under this chapter is examiner being successful in confusing you. So that's what they hope to achieve, to confuse you so that you don't correctly answer the questions. So that's how they can be tricky. But in terms of you identifying those 2 points and calculating, it is as easy as explained. So also, now if they say determine an equation of a g, you still do the same. You start with the general formula which says y or g of x is equals to a over x. Then you need to remember that, okay, for this one, I think I just need 1 point. Then that 1 point, obviously, it is that same point. So now, at that same point, what you do is just to substitute the y value and that, then you get the a value. Then you give your equation being g of x is equals to whatever the a value over x. That's all. So some more questions may be asked based on that information. So I think the last thing that I would like to explain, let me quickly see. I think quickly, very quickly, let me explain a parabola so that starting tomorrow we start answering some questions based on this type of functions. So I think I'm just going to remove all of that. Remember, guys, it's not at all the times where all information will be released in just one lesson, but as we do some exam type of questions, that's when we will discover some more parabola. The reason why I want to quickly finish off this part of parabola is because it's not really long, and again, tomorrow I want us to start having a look at exam type of questions. In most cases, they like using 2 functions. Either they give you a straight line and a parabola, or a straight line and a hyperbola. So this one is short, but let's quickly try to see how it looks like. Also, we still have those guys. I think we'll always be having these guys for some time. Another one, Koketso also likes being part of those guys. So let's just add her there. So the general formula, Bantu Bakiti, it is just y is equals to x squared. This is the general formula of a parabola. A parabola, the other word is quadratic. So this words, linear, we've dealt with that as linear equation. We've dealt with a quadratic equation. We've dealt also with a linear pattern. We've dealt also with quadratic pattern. So now we are on linear function and quadratic function. So that means linear can be represented as an equation. It can also be represented as a number pattern. It can also be represented as a function. So we are now on function. Same explanation goes for quadratic. So this is the general formula of a quadratic or parabola. Remember, how do you know it's a parabola? That's if you have a to the power of 2. It doesn't matter whether it's x squared plus 2x plus 7, but because of x to the power of 2 quadratic, that's what makes an equation to be quadratic. So now you have x and y. There's always that letter, Moleboge, that tries to complicate things. In this case, is letter A. Where is that letter A? Let me now update that and say it's actually ax squared. Now this is the general equation of a parabola. So can you see y and x? There's no need to dig info on those, but the a value, what is the impact of the a value on a parabola? Again and again and again and again, bantu bakithi, we draw functions on a Cartesian plane. So that is why at all the times I'm going to start with that, having the first, second, third, and fourth quadrant. The shape of a parabola is either that or that. So the impact of A, if A is positive, then you are going to have that shape. If A is negative, you are going to have that shape. Moleboge, let's talk again, honorable member. Sometimes
Yes,
it might not be easy to remember which shape, but would you agree with me that if your mood is positive, you'll be smiling, and then if your mood is negative, you'll be sad, isn't it?
yes,
Yes, so that is why we say if A is positive, you are going to have a smiling shape. Can you see that smiling shape there? It's because
yes,
of we are having a positive A value. But let's try and have a look at a sad shape. So that means if the A value is negative, we are going to have a sad shape. It's easier to remember now, isn't it?
yes,
Okay, it's fine. So now, let me give practical example. If you are having y, it's equals to, let's say, positive 2x squared. That means we are going to have a smiling shape because the a value is positive. So that smiling shape is going to make a U-turn at the origin. So that means you're going to have something similar to that. Maybe we can call it Brahma Franco. And then maybe you have y is equals to a negative x squared. But now, can you see, it is necessary to now specify because we're having more than one function. If it was just one function, then we're just going to say y. But now, because we are adding another one, we make use of those letters. Maybe let me say negative 2. You will notice why. So that means negative 2 is going to be the same as that, but having that shape, a sad shape. But now, what is the impact of that a value? What if this a value, it is no longer 2, but is 3? Because 3 is bigger than 2. So that means the bigger the value, the happier you get. So this is you smiling there, and then now you are having a bigger smile because of the value, the a value is increased. So that means it opens wider when that value increase. If it's negative 3, it opens wider. Something of that nature, if you understand what I'm trying to say, guys. Or you might find that if this a value gets bigger, maybe the function gets narrower. If it's negative, for example, -1, -1, it gets narrower. So that's why they would give you an investigation to say, investigate the impact of a value on a parabola. That means they want to know what happens if that a value increases or if it decreases. Then all that you would do is to try to substitute the x values where here maybe it's 1 or 2. You also do the same where here is 2. You also do the same here is 3 and 4 and whatever. Then you start plotting and you compare. But it doesn't really matter that much. But I just wanted to explain the impact of A. So something very, very much important while we are still on this type of a function. It doesn't end there. This equation evolves to become something a bit complicated because they realize it's easy when it's like that. So maybe they say y is equals to ax squared and they say plus q. So now I've just explained what the impact of A is. Now I want to explain what the impact of Q is. At all the times, just know that Q refers to the vertical shift. What do I mean by the vertical shift? So I mean the whole of this function can shift vertically, obviously upwards or downwards. The word vertical shift does not mean shifting upwards. It means shifting either upwards or downwards. Let me maybe remove all of these and try to explain something which could make sense. Maybe let me start with a straight line. For example, a straight line, it was just y is equals to mx, where it was just passing through the origin there. If you remember, I said there is that plus c there. This c, it has the same purpose as q, the vertical shift. So what I mean by that is that if you have a straight line passing through the origin and we shift it by 2 units upwards, then it means it's going to shift by 1, 2. Then it will be passing in that same angle, but passing through that point. That is why this is going to be y is equals to whatever m, then plus 2. That plus 2, it means it shifted 2 units upwards from the origin. If it was y is equals to whatever m, maybe minus 4, it's going to pass there at negative 4. That is the impact of the vertical shift. And then that of the gradient is, if it's like that, we know it's positive gradient. If it's like that, for example, can you see it's passing through that point, which could be 1,5, 1.5, or 3/2. So that means for that straight line, it's going to be y, whatever the gradient, plus 3/2, meaning it shifted upwards by 3/2, which is 1.5. The same as that. It's going to be whatever y value, mx here, it's negative 2, then it's going to be minus 2. So that is the impact of that c value. But when we deal with a quadratic, we talk about the q value. So that means, for example, if originally you had a function which is like that with a z shape. So let's say that one, it was y is equals to negative 2x squared. Suddenly, an equation now it has plus 2. That means this same function, it is now shifted by 1, 2 units upwards. How does it then look like? It is going to then look like that. That is why you will have a function no longer making a U-turn at the origin, but somewhere up there. It is because of that vertical shift of 2 units upwards. Similarly, with a smiling shape, let's say it was doing that, passing through the origin. Maybe let's say it was y, obviously a positive a value, which is positive invisible 1, and then suddenly we have a negative 3 or minus 3. This is going to be the vertical shift, meaning it's going to shift by 1, 2, 3, negative 3 units downwards. And then that is why it is going to look something similar to that. What makes it to be complicated is that it now touches the x-axis there and there for this one. And then for that one, it touches there and there. Then they would make it complicated, which is what we'll be looking at tomorrow. Not really complicated. It gets complicated if you missed this type of a lesson, because everything builds up to that. So let's see, x and y. Maybe we have that being that. Maybe this is f. And then now they can just do a straight line there. And then they give you this point. Can you see this point where that and that straight line cross or touch? They can maybe call that point point A. Why point A? It's because they want to make it easy when they want to ask you questions. When they say point A, they are referring to that one. And then maybe that one also, they can refer to that as point B. Oh, there's another interesting point there that we can refer to that as point C. I think even this one also, we can refer to that as point D. But most importantly, let's label that straight line and give it a name and say G. Obviously, that point there is the origin, so that's why I'm going to put O there. Remember, we're having the X and the Y axis. So can you now see, it now starts to get deeper. We haven't started with the calculations, we're just doing the talking. You will see when we start, sometimes it gets tough, Bantu Bagiti, but we'll see how it goes. So now you need to be aware that without doing any calculations, I'm about to wrap up on this. We're not going to do any calculations, but we'll see those tomorrow. But let's try to interpret this. At this point, at point A, that is the point where the graph of G is equals to the graph of F. Why a Lechumil? It's because this is where these two graphs touch each other. Where they touch each other, it means they share the same point. Where they share the same point, it means their point is the same. That is why we say they are equal at that point. Is there another point at which those two are equal? Anyone who can confirm if there's another point where those two, where?
Point C.
Yes, even at point C, that's where the graph of F is equals to the graph of G. I'm telling you guys, the reason why you fail this type of questions is based on the fact that you don't know at which points are the functions equal. Not knowing how to interpret a given function, it's another problem that we'll also try to look at as we go deep. And then at point D, that is where this function cuts the x-axis. That is a point that we call the x-intercept. That's where the word comes in, the x-intercept. So otherwise, the intercept mean where it touch. So we're simply saying at point D, that is where this graph touch the x-axis. At point B, that is where this graph touch the y-axis. That's why we say it is the y-intercept. And at the same time, at point B is the turning point of this function. Sometimes it might be confusing to understand what the turning point is. So this is what happens from this side going to this side. This is what the function does. Can you see? It's going in the upward direction. Suddenly it's turning. So where it's making a turn, we call that the turning point because it turns in that direction. If it is this, it does that, suddenly it's making a turn, then it does that. This is the point that we call the turning point, TP, the turning point, TP. So from time to time, I'll be using these words, the turning point, the x-intercepts, point of intersection, the origin, whatever, coordinates point. That is the terminology used under functions. So you need to understand what I'm referring to when I say the turning point. So that means you'll only hear the turning point when we're dealing with these. As we go deeper, we will be talking about things like asymptotes, the axis of symmetry, and whatever. I'm telling you guys, everything has an explanation. There shouldn't be a thing that is being said and you don't understand what it means. Don't always assume that, okay, they call it an axis of symmetry, and then because it sounds like a fancy word, then you assume it's something difficult. You know, it happens where you just assume that because, hey, it's a word that you're hearing for the first time, then you assume it's difficult. Nothing is difficult. There is an explanation for everything. What happens is examiner try to ask questions in a tricky way or in a confusing way, of which if you don't know or understand the tricks involved, it's going to be tricky for you to answer the questions. So how I managed to overcome this chapter, it was to do a lot of questions based on functions. Then I got to a point where I realized how questions are asked and how questions are answered, making use of the question paper and the memo, which is what we are going to do. All of this is what, for example, they would explain to you in class, do 1 or 2 question paper and say, we are done. Then, you know those old teachers who didn't even measure in maths. They just say, I just teach this subject. You will learn with the learners as you teach them. They just give you a background, then 1 problem, 2 problems, 3 problems. Then after exam, the highest mark is 13%. Then they will be asking everyone, didn't we do this in class? We did them. Didn't we do them? Then you say, yes. Knowingly that you did, but you did not understand how tricky questions can be. So to
Very
avoid
true.
all of that, we do this, and then what follows next, we try to answer exam questions. That's what I would do. With this lesson, it's enough, and then going forward, it's just question papers. I'm telling you guys, it got to a point where I realized that sometimes there are those teachers who teach some things they also don't understand themselves. That is why you will never see them touching a question paper. They will just look at your question paper and they never touch it. They just teach you, but you never see them solving a question. So for those of you who have those teachers who solve the question papers, you guys are very lucky. Some of us, we never had those, but if you have a question paper and a memo, you can learn a lot by yourself. I think, guys, we can just leave it there for now. So this is what happens in most of my lessons, guys. The lesson is supposed to be 1 hour, but it went for 1 hour 30 minutes. Yesterday, I think it went for 2 hours. The reason to that, Mr. Alex, is because we are now doing an introduction, and we're still going to do the same things towards you guys writing exams. I'm telling you guys, we won't take this long. Sometimes it could even be a 34 minutes lesson, and you find that we have covered 3 hours worth of work. That is because you know all the basics, which is what I'm explaining today. When we prepare for exams, we just discuss different question papers. We are not solving them. We just discuss those to say it's given in this manner. This is what the question is asking. That means this is what you need to find. As soon as you find that, you use it on this question, and then you use this on this question. That's how we discuss maths. We don't solve questions during exam, because you might find that you spend a lot of time on one question, and then from there you're tired. The time to get tired is now, where we spend a lot of time on these things and make sure that we understand those. So remember, guys, you did not engage a lot on this lesson. I also did not expect you to engage a lot, because to some of you guys, it's a first lesson. So what you need to do tomorrow, before 12 o'clock, this lesson is going to be posted. You need to quickly catch up before our lesson for tomorrow. Starting from tomorrow, we now do some real stuff where we solve for exam type of questions. So you cannot afford to miss the lesson for tomorrow. Guys, today I'm not going to ask anyone to sign out, just in case if you don't allow me. But otherwise, thank you very much for joining. My name is Desmond. You guys have a very good night, and I'm out.